we need to ensure that in the future, the most powerful AI systems, or at least powerful enough AI systems to be very competitive on the landscape, remain open source and remain accessible to everybody.
Hey everybody, I'm Titus, the VP of GTM at Civic, where we're focused on enabling secure agentic AI for both technical and not technical people. On this show, we unpack what's happening in the AI space, agent ecosystems, tooling, security that keeps everything running. Now, before we begin, as always, please don't forget to like, subscribe, follow us on your favorite platform. Your support really makes a difference. Now, today we are joined by Oleg Golev from Sentient. We'll be exploring open source AI, why interoperability and developer incentives matter, how transparency and alignment are critical to building AI systems that people can trust. Oleg, welcome. It's great to have you on the podcast.
Thank you, Titus. I appreciate the intro. I'm happy to be here. Hi, everybody. My name is Oleg. I am the product lead for the AI division at Sentient. Happy to answer any questions and talk about the future of open source AI with everybody.
Awesome. So let's start with the most exciting thing you've worked on recently at Sentient. What are you guys building? What's super cool right now?
Good question. Everybody will find out quite soon what we have been building in the past few months. It's a very common question. People are asking, what's new? What's new? I think our latest release was Crypto, which is a top crypto reasoning agent. But that was one of the things we were trying to wrap up, not any of the new projects that we're undertaking. So if you want to know what really excites me about Sentient right now, it's things that everybody will get to know a little bit more about in a few weeks. It's something very new, something really crazy, and hopefully something that gets quite a lot of traction. I think people should expect quite a lot going into 2026, where Sentient, now with quite a big repertoire of research under their belt, is able to deliver a lot of very exciting updates for everybody.
Very cool. So, zooming back out, for people who are new to Sentient, what is it? What do you guys do? What's the story behind it?
The TLDR is Sentient Labs is an AI research lab. We do AI reasoning research specifically. We teach systems how to think better, and we want to get community involved in it because at the end of the day, we believe that the way we can scale open source systems to combat and compete with closed source systems to allow better access, cheaper access, safer access to powerful AI is through open source. And so we're building this coordination and co-development layer for AI while we ourselves are leading it by example as a research lab.
Awesome. So, what from the current AI landscape made you guys like start doing what you're doing? What do you think is broken today? What needs to be fixed?
Absolutely. The problem is very simple. The problem is that the power of AI is so great, and yet it is centralized within a set of very few entities. We're currently seeing large raises and insane traction for the biggest players like OpenAI, Anthropic, and Google, and at the same time, we need to ensure that in the future, the most powerful AI systems, or at least powerful enough AI systems to be very competitive on the landscape, remain open source and remain accessible to everybody. We want to avoid a future where just these few entities control the things that control our media, control the biases and the articles that they write. If just a few entities control AI, I don't have to justify why that's dangerous. So we're just trying to be that counteractive force and make sure that open source development is rich and sustainable, and so that we can have not only amazing models, but amazing reasoning systems and applications on top of open source.
So, was there like a specific moment that convinced you open source was the path forward?
It's not for me, but for the founders. They always tell the same story of seeing how many AI developers there are in the world, and then saying, I don't know what they're doing. I don't know why they're not being, rewarded. I don't know why they're not being, involved in this world of rapidly growing AI. If you look at Hugging Face, if you look at GitHub, there are quite a lot of AI builders that are experimenting, trying things. Some are toy projects, some are not toy projects, and there's no way for you to really a coordinate them in a productive manner, and b there's no way to really prove whether something was good or not good. And so the parallel problem is that there are a lot of AI developers that are trying to do something interesting, but there is no company that is really trying to organize them in any sustainable way in the open source ecosystem. The only way that companies do organize such developers is hire them and put them on the project rather than let's solve problems that people care about, that people voted for, get people together in some framework and build something actually useful. And so we see that there is this trend towards AI centralization, which is kind of a mission driven problem. And then there's the issue of there are a lot of AI developers who have a lot of talent, who have time, who have a lot of interest, but not as much opportunity. And so that same coordination framework that would enable us to better compete with closed source and coordinate open source AI development would also enable these developers to come and get rewarded for their contributions, grow, and hopefully we create a future where people don't even have to be quote unquote formally employed and just contribute to open source AI in a productive manner as a skilled developer and be able to I guess pay your children's education that way.
Yeah, that makes sense. A lot of people are saying like, well, how do you compete with a well-funded company like OpenAI or Anthropic? And I think the community aspect is one of it. Do you want to add anything to that?
You're absolutely right. You're absolutely right. This is why we think it's a worthwhile problem to solve. The first, company, organization, whatever, even government, if they're interested, to solve the problem. That's the problem we're solving. To solve the problem of how do you get a lot of people to work together on one problem in AI, will suddenly solve quite a lot of other problems because then you can translate it to well, now we solved it in AI, and now we can use the platform for any other type of software or later, you can even say we can use it for any type of hardware, go into robotics, and so on. And so, this fundamental problem of building a platform for collaborative development is extremely critical to being competitive with people who have much more money. Because even if we, as an open source platform, wouldn't have as much money, we will have a lot more resources and a lot more talent. And that will eventually translate into a lot more money for everybody.
Well, and also the perception I think is that you need more money because the models are getting bigger, and to get better results, you need a bigger model. And I mean, I think there's competing schools of thought there. I think like we've reached a point where bigger doesn't necessarily mean better in a lot of ways, and for a lot of use cases. What's your thought on that? What's your thinking on that?
Yeah, and this is a completely fair argument. And I would say that this argument was extremely valid in 2024. And I would say it was still somewhat valid in the beginning of 2025, just before DeepSeek came out. Just in the second half of the last year, we have seen so many open source model releases that are almost as powerful or as powerful on certain metrics as the closed source alternatives. And in parallel, the cost of inference has also been going down. So not only is it that open source models are now much more effective at specific jobs that are most targeted for by these AI developers, it's also much cheaper to host them, or you can go ahead and buy your own hardware and self-host them if you would like. So I think that it was definitely a great argument in 2024. I think now that we're going into the year 2026, likewise, the rise of SLMs, small language models that are very hyper specialized in certain tasks, let's say content extraction and summarization, tool calling for a certain industry. We've been going down this route of reducing costs and maximizing model efficiency, and models have just generally become much, much smarter. So I don't think it's as big of a problem anymore as it used to be.
Yeah, it's interesting to think about that in terms of how we also work with people and with teams. Like, you won't bring in an expert on everything. You need somebody to do a very specific job. You need a marketer, you need a Python developer, you need a salesperson. Like, all that is specialized work that doesn't require infinite knowledge or complete knowledge of
Yeah.
everything else.
Yeah, absolutely. And this is exactly what we've been seeing, right? We've been seeing this flexibility to choose your own models for whatever you wish. So using your example, if you want to make a AI company team, you would have your marketer, BD, engineer, product guy, CEO. Um, you could theoretically use, let's say, DeepSeek R1, um, or GPT-5 or Gemini 3, these really big and really expensive models. Even R1 is I mean, it's a gigantic model. Um, you could use those models for all of these tasks just by using prompting, but people have been developing these specialized small models, so you can get 10x, maybe even if it's a good model, 100x reduction in cost and latency, at basically no performance cut.
Yeah, that makes sense, especially at scale, because like, hey, those credits add up really quickly
Very
for the consumption.
very quickly. Anybody who's ever tried Claude Code will tell you credits stack up fast.
I mean, I remember when I was building my own company before joining Civic, my first OpenAI bill was like $2,000. I'm like, how?
Yeah,
We're only processing like a few thousand web pages. So
yeah.
anyway,
All the bigger evidence that good open source AI is needed. It's cheaper.
yeah, I mean, it's especially if you can like run it locally or like on a regular GPU as opposed to like the high end ones. That all already makes a huge difference.
Absolutely, absolutely.
Yeah. So I think one thing that strikes me with all of these models is like, how do you think about interoperability? How do you make sure they can work together? How they collaborate? I think that's been on my mind as I was reading through this part of the open source ecosystem.
I know people ask this question a lot because my background is engineering. I don't know why people ask this question a lot, actually. So in the same manner that when you bring a team of people together, if you just, let's say, hired willy nilly somebody into a company and you put them in the same room and then said work together, um, they might not work together very well. Some people might work together well, some people won't. And some different combinations you might try, or some ways to arrange them with different instructions you might try. And eventually they will hopefully come to, some weight of operation. And maybe some of them were not necessary because, you hired wrong. So bad example, but pretty illustrative. You get models to work together at their strengths, and it will obviously take a little bit of trial and error. Each model will come with its strengths, each model will come with its weakness, and it's up to you and also the creators of the model to figure out what these models are best for. So when I talk about how do models coordinate, I always say you bring the best tools for the job, and to figure out what tool is the best for the job is your responsibility.
So you have to be a bit prescriptive when it comes to like, hey, model one do this, model two do that, model three do that.
Yeah, and we obviously, this is not a brand new idea. People have been building orchestrators from a long time ago. So if you want to build your own AI orchestrator, you still have to prescribe to that orchestrator, saying, "Hey, man, like this model is better at that. This model is better at that." You have to be prescriptive. Either use it for yourself and in building some certain AI workflow, or you describe the same information to an orchestrator model that will just go and control other models as well. So you do need your own knowledge, and it is your responsibility to figure out what you need. There's no magic button. There's no like magic world where you just say something and the AI will figure it out by itself. AI will necessarily need to do that, a way to self-reflect and self-evaluate. And as of now, that's not really useful. It's much more useful and more effective for you to just evaluate AI and then tell AI what to do.
Yeah, and it's almost like if you can't solve the task on your own, it's going to be very hard for the AI to do it for you if you don't know the task well enough.
Yeah, exactly, exactly. If you can't tell AI at least somewhat, even of the vaguest steps of what to do and what systems or what tools or what data to get, then AI probably won't be able to figure it out either. Obviously, some accept, obviously, like more or less, sometimes it is able to do that, but not in the case of model orchestration. AI models don't know what's good and what's bad in terms of model performance.
Well, to be fair, there's not a lot of content out there either about like which model performs better or not because everything is very new.
Too many models and too quickly, right? People are just trying, and it's all completely experiential.
Yeah, and it's like, I think for me it was surprising almost to hear you say that DeepSeek only came out like early last year, which feels like it was around for a while.
It did, right? It was only the beginning of
Yeah,
last year.
yeah, it's crazy how fast the world is moving, and I feel like the one of the reasons we're doing this show is like to help people kind of keep up with the newest things out there, because everyone's moving like now at 10x or 50x speed thanks to Cloud Code and like the open source models and OpenAI and like all these ecosystem players. They're all contributing to effectively every one of us that are using AI every day to work faster and better.
Absolutely. And I really like that you just made this point or re-emphasize this point. Back in 2024, one of the biggest and baddest models was ChatGPT 4.0 and 4.0 mini. And basically, any model coming out nowadays in the open source is much smaller than 4.0 with 4.0 mini. And note just how much rave and how much hype people were giving 4.0 back then, so a year and a half ago now, saying how this is the future, how we're almost at AGI, how it's able to code so well, how it's able to do this and that. And the best alternative at the same time was just Llama. And I'm going to tell you right now, in all honesty, Llama is an open source model. It's really bad. It's, it was good by metrics back then. It was bad by modern metrics now. Um, but I would say 4.0 is still okay. And so that's why I say 2024, the landscape was very different. People were saying, these closed models are so powerful. Llama was there, but Llama wasn't that good. And nowadays, we see such a tight gap now between open source and closed source. We see the small language model training and specialization. Um, Open source has become very powerful, but also models in general have become 2x, 3x of what they were, even though people were raving about 4.0 just a year ago.
So I want to make one more point around the interop piece. So we talked about cost saving being an obvious kind of benefit of it, like getting 10x, 100x, sometimes improvement in cost by using models for different skills and different purposes. Are there any other like benefits the developer would have by using these different models for their purpose instead of using a single model?
Yeah. But, I mean, the three biggest things that everybody cares about: performance, cost, latency. If you have a very finely tuned task that you want a model to do, and you want to create a model that is finely tuned for that task, well, it will be good at that task. You get a better performance. As a result, if the model is also smaller than what you would be using otherwise, then you end up with lower latency and lower cost because the model is smaller. So it's beneficial in basically all the three major axes that you care about: performance, cost, and latency. It's just that you have to figure out how to do the fine tuning, right? So you need a pretty good tool. I know that Tinker came out recently with their newest tool, very interesting. But a lot of open source tools out there that are no worse, that you can go ahead and use to fine tune your own models and see some pretty good performance gains. If you want something that does content extraction, or thinking about your shopping list, I don't think you need to use R1 or Gemini 3 for that. I think you can get a small model to do it. But
Yeah, sounds like the market will go in that direction as essentially like we're seeing more specialization in these startups and in the ecosystem. They're more purpose specific rather than general ones coming out, and they're trying to own the vertical. And there's some defined tasks there that for sure a small model can do better, and an open source model can do better and more efficiently. To your point.
and one of the other things is fine tuning is cheap. So for people who will say, "Oh, fine tuning is expensive," and so on, how will I? So not only is an advantage of open source that things are cheaper and you can go ahead and have as much control over what you're using as you want, but as part of that control, you can fine tune quite cheaply your model and whatever you wish. And so as a result, you do truly have 100% control over whatever you want to do. So when you consider collaborative development, right? What Sentient is really all about. leading by example, leading by the research we do, and inviting people to contribute. The bar, I guess, to contribute, and also the bar to contribute, not just at the agent level and the application level, but also the model level, is relatively low, just because of how powerful models have become and how cheap it is to fine tune them now. It's all
Yeah,
in.
that makes sense. And this is where I have a bit of a contrarian view from like a non-developer standpoint. For me, it's easier to reason the kind of let's handle everything at prompt level or at instruction level, and let's prime the data itself, the payload, the context, rather than improve the model itself. But it sounds like the industry has shifted now, and it's like now it's possible to do both and get even more efficiency out of it.
That's right. It's possible to do both. And let me say this. What you're talking about is in context learning, right? So the ability of the model to learn just from the prompt given to it rather than from its weights. And so far, up to this point, one thing that has been happening over time is we have been getting models with larger and larger effective context, because model developers have truly been relying on in context learning to patch in the gaps for the users when the users want to use it for things that they're not trained on. So exactly as you say, if I want to use a model for a specific purpose, I just describe that purpose. I give some examples, and there's lots of techniques on how to properly, prompt engineer LLMs, and presumably it will work pretty well. And this is still a hypothesis that a lot of these model development companies are following. They're just saying we were going to continue our training algorithms in such a way that we keep extending that effective context window so that we get models to do better and better in context learning on larger and larger corpus. So you can provide, in simpler terms, you can provide a bigger prompt and it will still follow it pretty well, even if nothing like it was ever in the training data. Uh, that is still one of the things that model makers are doing. It's not a 100% solution. So fine tuning is still there and it's going to stay. If we come up, in the future with some way of ensuring that in context learning is truly as effective as fine tuning over long contexts, then great. I will be happy to live in that future where I don't have to retrain anything. But nonetheless, open source models will still be cheaper.
Yeah, and it helps you avoid the what's it called, the dumb zone, where you like flood the model with too much context, and then you kind of end up with worse results that you
Yes.
started with. Yeah,
Yes. For all who doesn't know and want to look it up, it's called context rot. If you put too much context in, your performance degrades. So if you same thing as you walk to a human and you give it one page and say learn this page, they'll probably memorize it. If you walk to a human and say read this book and then take a law exam on this law book, I don't think they're going to do too well.
well, not immediately at least. It'll take them a while to
Yeah.
fine tune their neural net with
That's
that
the
book.
fine tune. Exactly, it's fine tuning. So in context
Yeah,
learning is this kind of I got it now, but if you want to read a book on law and practice law, I think you'll need a fine tuning method, not a in context learning method, at least for now.
yeah, exactly. All right, so let's switch gears a bit and dive deeper into advanced reasoning and what you guys are doing at Sentient.
Sure,
Um, what does that entail? How do you guys achieve top tier reasoning in open source models?
sure. So let me preface the answer with defining reasoning. To me, to me, and to I would say most people at Sentient, reasoning is the idea, uh, or rather the method of discovering something out of distribution. If you didn't need to reason about it, it means it wasn't out of distribution, and it means you knew it. So if somebody asks you a question, who is the president of the United States right now? I don't have to reason about that question to come up with an answer to you. I just have to know it or either don't know it. So either it's within my distribution or out of my distribution, it's completely determined. Anything that's truly a reasoning task is always going to be more or less out of distribution. I need to walk through a bunch of steps that I have learned how to process, how to reason, how to think, and then I will come to my answer. And so this is both a model problem and also an agentic problem. This is where you hear things like RL, trace data, reasoning traces. If you ever see these kinds of terms being thrown around, people are talking about reasoning models or just creating reasoning systems. So the difference is, if you're using a reasoning model, the model will go ahead and kind of spend its tokens thinking before answering. And so we saw that when O1 came out, or when R1 came out, you would go on ChatGPT or you would go on DeepSeek's chatbot, and you'll ask a question. We'll go and self-reflect and think, I will go and do this. Maybe the user means so and so and so. And so this was the birth of the reasoning models. But before the reasoning models, and also still nowadays, you can use non-reasoning models for the same purposes. The only thing you just kind of have to do is you have to make a for loop. You just loop the thinking, you loop the model around itself, and then ask it to think. And the result is somewhat the same. Now you can also put reasoning models in the same construct with data and other things that it is able to access and think about. And what you get out of it is you get a kind of a sequence in response to any user question. You get a sequence of actions that the system takes as it reasons through the question, considers this environment, considers its tools, and finally produces the final answer. And so whatever data you get out of that is extremely valuable data because it teaches you about how the model and the entire system uh, has gone about the reasoning process, whether the reasoning process has achieved success or whether the reasoning process has achieved failure. And you learn from the failures, and then you take the successes and use it for fine tuning, right? So that's one of the simple examples. So you build complex systems that follow certain reasoning processes, collect the data, and then fine tune the models to reason better, so that hopefully you don't have to build the systems as complex next time, so that the reasoning will come innately with the model. But if we keep doing that process, eventually, the argument is eventually will there be anything out of distribution? And the belief is there will always be something out of distribution. And so the faster we get to this point of being able to arrange these agentic AI-driven systems in the most flexible way, the closer we get to systems that actually can reason without having to be trained on anything. So we were talking about in-context learning as a way for teaching LLMs to think about things they're not used to thinking about, but putting multiple LLMs together, putting tools, putting data, um, putting some constructs between them, like decompose this question first before answering, and then let's say each part of the question would go into its own processing loop or something like that. Being able to architect these reasoning constructs of decompose, think in parallel, loop back, reflect, self-correct, all of these architectural reasoning constructs should be completely flexible and reflective of the way humans think, and then later should be reflective of the way that AI will by itself guide itself to think. We will, I'm sure, we'll discover a way that AI can think more effectively than humans, and will think differently than humans, and that's how we continue, to either build these systems and also train the models in that direction. Um, so that's a lot of information, but the TLDR is reasoning is thinking outside of the LLM's distribution, and the key to building great reasoning systems is building or making an environment where you can flexibly experiment with different architectures and different components of architecting AI systems. And I guess the better that auto architecting becomes, the closer we get to a world where, given any query or given any task, I can go ahead and stand up the perfect reasoning execution pattern for you to go from that task to its perfect successful completion.
And that's very cool for a number of reasons. My favorite one, I think, is because it replaces the whole kind of rigid workflow thinking that we've had right now. Like take traction in the market with the N8Ns of the world, the Windmills of the world, where you have to like build every step in a fixed system and whatever breakout whatever edge cases and use cases you may have. Whereas in this case, you would let the agents think it through and achieve the result that you've set to achieve
Sure,
ultimately.
sure. And there is some guys who have been doing this also automated N8N creation, where you just say, I want to get this done. And the moment you say that, you don't have to drag and drop anything. You don't have to build anything yourself. You don't have to prescribe anything. You just say, I want to do this. And then what you get on the other end is, a perfect execution graph that describes what exactly will happen to achieve that task. That just happens. It looks like magic, but um, that is a great example of what I mean by reasoning systems that should be completely adaptive and maybe even self-creating or self-architecting.
So I know you guys built Roma a few months ago, right? We released it, and can you explain to listeners what it is, what problem it's solving, and how does it work, and talk a bit more about this like multiple specialized agents, unified workflow? I think people would love to kind of deep dive in that.
Yeah, absolutely. So Roma stands for Recursive Open Meta Agents, and it's a framework that we published earlier last year. The framework essentially is for you to build an agent that follows certain conventions, and the conventions are mostly reliant on decomposition. So the problem that Roma is solving is that a lot of the system nowadays um, are very ineffective at breaking down tasks and also managing context over long horizons. So what I mean by that is if you give some agent a very difficult problem, for example, um, give me, for all the digital nomads who might be listening to this, give me the visa requirements to every single South American and Southeast Asian country, given my nationality. For each country, give me blah, blah, and you get the point. And so, as frontier systems, as you're building systems to tackle this kind of problem, you end up in a situation where, as the AI system is gathering more and more and more and more data, its context continues growing over time. As it continues thinking, it keeps growing and growing, so that it remembers what to do next, what it has done before, etc. And there's a lot of techniques like context packing, summarization, using file system that people now talk about for context engineering, but it's still a problem, right? You have to handle quite a lot of things. And so Roma said one of the methods to handle this context explosion problem is by just relying on decomposition and isolated context. So if I give you a task like that, what Roma will do is it will take the task, it will just break it into however many smaller subtasks. And those will have their own isolated context. And they will not see each other's context unless absolutely necessary or when necessary. And then each one of those subtasks goes ahead and breaks down into smaller subtasks and smaller and smaller and smaller and smaller and smaller. Um, if you've seen Alex Zhang's from MIT's paper on RLMs, recursive language models, Roma was actually the first instantiation of the idea. It came out before RLMs. And so that's what Roma is, in practicality. It's this hierarchical tree um, uh, thinking structure for agents to be able to handle long horizon context better and be able to process effectively large volumes of information. And we saw good results on benchmark. We saw amazing results on frames search benchmark. We saw amazing results on seal QA search benchmark. And also we tried it on creative writing. Um, it surprisingly did very well there as well. So some very interesting discoveries, some good state of the art numbers, and we're continuing to think, further into how to improve that repo, but also how to combine the ideas of Roma, this kind of context management and recursive context management, to maybe create something a little bit more generic. Because it is completely true that not every problem should be solved in the way that Roma, prescribes them to be solved, and we should be a little bit more flexible. But it's one step towards this self, quote unquote, self architecting idea that I mentioned just earlier.
think one of my biggest challenges with flow like that is like what happens if one of the sub tasks or sub agents ends up going off the rails or erroring out. Does that then cascade into the first, like the latter part of the process failing, or is there some recovery mechanism that you guys built in? Like, how do you handle that?
The whole point is that this is actually a much, much better structure for error recovery than any iterative process. A recursive process is essentially going to be much better at error recovery because there is less data to deal with, and AI is able to much more quickly recognize from a smaller pool of information available to it what went wrong. And so so on a theoretical level, recursive structure like this is actually much better at error recovery, and we've seen that with other recursive papers coming out in the recent few months. I think the Towers of Hanoi paper, where they used the recursive structure to go and do a million steps with no mistakes, right? Like that is an extremely amazing achievement, and recursive structures have been able to get that for us. Um, so solving the problem of error propagation in terms of practical sense, that's just an engineering problem. But in theory, recursive systems are much more resilient than iterative ones for this kind of error.
Makes sense. Makes sense. So I want to zoom back out and come back to the kind of ecosystem and community discussion we had at the beginning of our conversation.
Sure.
And I think one of the things that stands out in both like from a developer standpoint and contribution to the open source community, but also like from a agents and especially for these recursive agents put in practice, like how do you set the right incentives both for the person, but also like especially for the agent to stay on task and to like stay loyal in a way, if you want to what you set it off to do versus kind of be distracted by the system it is now in.
Yeah. So I think what you're asking, and correct me if I'm wrong, is if you prescribed an agent to do a certain task and you deployed it to do a certain task, how do you actually make sure it does that task?
Yeah, have it stay on task, exactly.
100%. It's a problem. If you describe a task of handling payments to an AI agent, deploy it, and then your AI agent starts forwarding all the payments to a shady wallet address somewhere in Nicaragua, I think something went wrong, and you should probably prevent that from happening. So that's the problem setup. What's the solution? Well, solution is many of the things that we discussed, and also some general engineering security. So one of the things that we've talked about so far is in context learning. So obviously prompt your things well, make sure that they know what to do, what not to do. But that's not never going to be secure because since the start of days, people have been stealing system prompts and doing some prompt hijacking, basically getting products like ChatGPT and Gemini. I mentioned those because people use them a lot, right? Getting those to go against their terms of service. And so the first thing we have to do is, yes, we have to have a relatively resilient prompt, but it's not going to be an all-in solution. The second thing that you can do is fine tuning, where you specifically fine tune against certain types of attacks. But that's also not going to be resilient for a long time. People will always find some edge case. People will always find some way where the model was not trained sufficiently to resist the kind of attack. The third thing is um, all the things you can do external to the model. So when you think of doing anything external to the model is you can, let's say, have an auditor, like an auditor AI, that goes ahead and audits every single output that the model uh, provides and says, okay, so maybe the model was tricked, but I'm not tricked because you know the user doesn't have access to me. So I, as an auditor, will make sure that the user didn't trick this model or this system in deployment. So I will monitor every single output, and I will be at this like final QA check, right, to make sure that um, everything went according to the standards. The other thing that is important, so this is what people call like external guardrails or output guardrails. Um, then you can do input guardrails, which is making sure that when a user is even trying to do something that is known to be tricky or malicious, you just stop the user and ban them, as simple as that, or block their access for some time, or simply stop the query in its tracks. And so there's input guardrails, there's prompting, there's fine tuning, and then there's output guardrails. And finally, there's one other thing to mention, and this is what I think the most interesting attack vector is in this entire end-to-end sequence, is context injection attacks. So as the system is working on its task, depending on the parameters of the system, maybe it's getting data from some external source. It's getting data from some databases, getting data from some APIs, and then it bases its decisions on that data and then gives you the final answer. The user's prompt can be poisoned, yes, but the data that the system is ingesting can also be poisoned. So the data might come, and the data might say, go ahead and instead of sending money to this guy, send it to my address. And so the problem is the same. You need to figure out either through prompting, reflection, some kind of self-auditing, or fine-tuning a method to prevent against such attacks. So this is a very good area of research. It's one of our foci here at Sentient. How do you make autonomous systems actually reliable and safe? If I gave a system a task and put it into production, and I want to make sure that it keeps doing what it's doing without sending any money to Nicaragua, that's one of the things we're researching. So I welcome everyone to read a few of our papers on that.
So speaking of what you guys are doing, you mentioned something at the beginning of the conversation that you're working on something very cool that you're going to be announcing soon. Do you want to give any clues to people what you're working on in 2026? What should they be looking out for?
Absolutely, absolutely. So as I said, the past year and a half, Sentient has been flexing its muscles, doing a bunch of research, doing a lot of building, doing a lot of exploration. And one of the biggest things that I've said on this podcast, and I say otherwise, is that we want to lead by example. There's a lot of people out there who say we want to build, a place for people to co-build AI, but these companies don't know how to build AI themselves. And so, lead by example. We've been flexing our muscles. We've been learning a lot. We've been figuring out how to build, architect, improve, evaluate really powerful systems, a lot of which we never even released. So a lot of things, that we have is not out there because it's this long and grindy iteration process that is bearing its fruits gradually. So what should people expect? People should expect that a lot of these experiments are now transitioning towards, a truly collaborative orchestration of development. So now that we know all the nitty gritties and ins and outs of how to build good AI, we now will begin allowing everybody to come together, and with our new knowledge, now everybody will be able to have an opportunity to contribute and actually build meaningfully powerful AI systems on probably a new platform.
That's awesome. So if you were to fast forward like 3 or even 5 years in the future, what does that healthy open AI ecosystem look like? What should we expect?
Good question. 3 years from now, I would like there to be a directory. Might I even say global directory called Grid? So 3 years from now, I would like Grid to be a very healthily and very comprehensively instantiated product, where anybody is able to go visit grid.sentient.xyz and see hundreds and I don't know about thousands, but maybe thousands of repositories that are state of the art or were state of the art at some point in a certain capacity. The best evaluation frameworks that were built by community, the best agents that were built by community, the best finance advisors, the best food critics, the best whatever your use case is. You go there, you type it in, and you get an audited, reviewed, and approved repository with very clear benchmarks, very clear value proposition, and very clear compete value against any closest alternatives for you to pull down, try very quickly through our own framework, and do whatever you want with. It's open source. You can customize it. You can build a whole company with it. You can go ahead and connect with any of the developers that built it. You can connect with other people who are interested in the same topic to keep building it. There's no limit to it. The main idea is there's a place where audited, reviewed, really awesome, state of the art, powerful AI systems live, and that is Grid.
Awesome. So, where should people go if they want to follow your work and as you're building the journey towards that 3 plus 2 to 5 year point?
Anywhere where Sentient is on X, on our website. Our X is probably the best place. So go ahead and give us a follow there, and we'll be excited to share any news with you.
All right. Well, the links will be in the show notes, so make sure to follow. Thank you, Oleg, for joining us. This is a super cool conversation. For everybody else who's listening in, if you enjoyed this episode, don't forget to like, subscribe, follow us on your favorite platform. It helps us bring you more great content. And don't forget to check out civic.com and learn more about what we do. See you next time on the podcast. Over and out.